Welcome to today's lesson on concrete step repair. When you see a damaged concrete step on your property, your first instinct might be to tear it out and start fresh. But here's what professional contractors know: many severely damaged steps can be repaired rather than replaced, saving you hundreds or even thousands of dollars. In this tutorial, we'll walk through the complete process of restoring a crumbling concrete step from start to finish. We'll cover every technique you need to transform damaged concrete into a surface that looks and performs like new. Before we begin the repair, let's understand why concrete steps deteriorate in the first place. Concrete is porous, meaning it has tiny holes throughout its structure. When water enters these pores and freezes, it expands, creating pressure from within. This freeze-thaw cycle, repeated over many winters, causes the surface to crack and flake away. We call this process spalling. Additionally, de-icing salts used in winter can accelerate deterioration by breaking down the cement paste that holds concrete together. Understanding these causes helps us choose the right repair strategy. The first step in any repair is a thorough inspection. A professional contractor examines the entire step to determine if repair is feasible or if replacement is truly necessary. We're looking for the extent of damage, checking whether the structural core of the step is intact. If more than 50% of the step is damaged or if there's significant structural cracking that goes deep into the concrete, replacement might be the better option. However, if the damage is primarily surface level, even severe spalling and crumbling can be repaired. We also check for any underlying issues like poor drainage that caused the damage initially. Let's review the materials you'll need for this repair. First, removal tools: a cold chisel, which is a hardened steel chisel designed for masonry work, and a hammer. You'll also need a wire brush and ideally an angle grinder with a wire wheel attachment for surface preparation. For the actual repair, you need a concrete bonding agent, which is a liquid that helps new concrete stick to old concrete. The repair compound itself should be polymer modified, meaning it contains plastic resins that make it stronger and more flexible than regular concrete. Finally, you'll need finishing trowels and a quality concrete sealer for the final step. Before beginning any concrete work, we need to address safety. Concrete dust contains silica, which can cause serious lung damage if inhaled repeatedly over time. Always wear a properly fitted dust mask or respirator rated for fine particles. Safety glasses are essential because concrete chips can fly up when you're chiseling. Heavy-duty work gloves protect your hands from both the sharp edges of broken concrete and the caustic nature of wet cement, which can cause chemical burns. If using power tools like grinders, hearing protection is also important. Never skip safety equipment to save time. Now we begin the actual repair work by removing all loose and damaged concrete. Using your cold chisel at a shallow angle, tap firmly with the hammer to break away any concrete that's already crumbling or delaminating, which means separating from the main structure. The key is to remove everything that's loose but stop when you reach solid, sound concrete. You'll feel the difference: loose concrete sounds hollow when tapped, while solid concrete rings with a higher pitch. Work carefully around the edges to create a clean boundary between damaged and sound concrete. This process might seem destructive, but it's essential for a lasting repair. After removing loose concrete, we need to create what contractors call a proper edge profile. This means the edges of the repair area should be roughly perpendicular to the surface, not sloped or feathered. Think of it like creating a small bowl or crater in the concrete. This edge profile is crucial because it gives the repair material something to grip onto mechanically. If edges are sloped and thin, the repair compound can easily pop off. Use your chisel to square up the edges, creating about a 1/4-inch depth minimum around the perimeter of the repair area. This mechanical bond works together with chemical bonding agents for maximum adhesion. Surface preparation is arguably the most important step in concrete repair. Even the best repair compounds will fail if applied to a dirty surface. Start with a stiff wire brush to remove all loose debris and dust from the repair area. For best results, use an angle grinder fitted with a wire wheel attachment to really scrub the surface. You're trying to expose the aggregate, which are the small stones inside the concrete mix. The surface should look rough and clean, with no dust, dirt, oil, or loose particles. Finally, blow out or vacuum all dust from the area, then rinse thoroughly with clean water and let it dry to a saturated surface dry condition. A bonding agent is a specialized liquid that creates a chemical bridge between old and new concrete. Think of it like a super strong glue designed specifically for concrete. Most bonding agents are either acrylic or epoxy-based polymers. When applied to the old concrete surface, the bonding agent penetrates into the pores and creates a tacky surface that the repair compound can chemically attach to. Without a bonding agent, you're relying entirely on mechanical friction, which isn't enough for a lasting repair. The bonding agent must still be wet or tacky when you apply the repair compound, so timing is important here. To apply the bonding agent, first ensure the concrete surface is slightly damp but not wet enough to have standing water. We call this a saturated surface dry condition. Using a disposable brush or roller, apply a generous coat of bonding agent to all surfaces that will receive repair compound. Make sure to coat the vertical edges as well as the horizontal surfaces. Work the bonding agent into the surface with your brush, almost scrubbing it in. Different products have different working windows, but most require you to apply the repair compound while the bonding agent is still wet to the touch, usually within 15 to 30 minutes. Polymer-modified repair compounds come in bags and need to be mixed with water, similar to regular concrete. However, these specialized compounds contain additives that make them stronger, more flexible, and more adhesive than standard concrete mix. Read the manufacturer's instructions carefully for the exact water ratio. Pour the specified amount of clean water into a mixing bucket first, then gradually add the dry compound while mixing. Use a mixing paddle attached to a drill for best results, mixing for 2 to 3 minutes until you achieve a thick, creamy consistency similar to peanut butter. The mixture should hold its shape but still be workable with a trowel. Now comes the application of repair compound. Working while the bonding agent is still tacky, use a margin trowel to press the compound firmly into the repair area. Push hard to eliminate air pockets and ensure complete contact with the prepared surface. Fill the area slightly higher than the surrounding concrete surface to account for settling and to allow for final shaping. For deeper repairs more than 2 inches, build up the compound in layers, allowing each layer to partially set before adding the next. This prevents slumping and ensures proper curing throughout the thickness. Work methodically to fill all voids completely. Once the repair area is filled, we shape the compound to match the original step profile. A finishing trowel, which has a larger, flat blade, helps create smooth surfaces. For a step, you want clean, straight edges and a flat tread surface. Hold the trowel at a slight angle and work with sweeping motions to level and smooth the compound. If you're repairing a step edge, use a straight board or edging tool as a guide to create a crisp, clean line. The initial finish doesn't need to be perfect because we'll refine it later with sanding. As the compound begins to set, you can continue to smooth and refine the surface texture. Proper curing is critical for repair compound strength. Curing refers to the chemical process where cement reacts with water to form strong bonds. This process requires moisture and takes time. Many repair failures happen because the compound dried out too quickly rather than curing properly. After finishing, keep the repair damp for at least 24 hours, and preferably 72 hours. You can do this by misting with water several times per day or covering with damp burlap or plastic sheeting. Temperature matters too. Ideal curing happens between 50 and 75 degrees Fahrenheit. Avoid working in extreme heat or cold. After the repair compound has fully cured, usually after 3 to 7 days depending on the product, we refine the surface through sanding. This step blends the repair seamlessly with the surrounding concrete. Start with coarse grit rubbing stone or concrete sanding block, working in circular motions to level any high spots and smooth rough areas. Progress to finer grits for a smoother finish. For larger areas, you can use a random orbital sander with specialized concrete sanding discs. The goal is to make the transition between old and new concrete invisible to the touch. Where your dust mask during this step as sanding creates fine concrete dust. The final step is applying a concrete sealer to protect your repair and the entire step from future damage. Concrete sealers work by filling the pores in the concrete surface, preventing water penetration. This stops the freeze-thaw cycle that caused the original damage. There are two main types: penetrating sealers that soak into the concrete and film-forming sealers that create a protective layer on top. For exterior steps, penetrating silane or siloxane sealers are usually best because they don't create a slippery surface. Apply with a brush or roller according to manufacturer directions, typically 2 coats for best protection. Reapply every 2 to 3 years for continued protection. Let's look at the transformation. What started as a severely damaged, crumbling concrete step is now restored to like-new condition. The repaired areas are structurally sound, properly bonded to the original concrete, and protected against future deterioration. This repair will typically last 10 to 15 years with proper maintenance, compared to the cost and disruption of complete step replacement. By understanding the proper techniques of surface preparation, bonding, application, and sealing, you can tackle concrete repairs confidently. Remember, the key to success is patience at each stage, thorough preparation, proper mixing, adequate curing time, and quality sealing. This is how professionals turn damaged concrete into lasting repairs. To keep your repaired step looking great for years to come, follow these maintenance tips. Reapply concrete sealer every 2 to 3 years to maintain water protection. During winter, avoid using de-icing salts on your steps. Sand provides traction without the chemical damage. Ensure that water drains away from your steps rather than pooling against them, as standing water accelerates deterioration. Inspect your steps annually, looking for small cracks or chips. Address any minor damage immediately with patching compound before it becomes a major problem. An ounce of prevention truly is worth a pound of cure when it comes to concrete maintenance. With these practices, your repair can outlast even some new concrete installations.